This is a really interesting next few months in space exploration, and I should say beyond space exploration to space settlement or becoming a what is best phrased a spacefaring civilization. Um, in the next few weeks, a new rocket company called Relativity Space is going to attempt its first orbital launch of a 3D printed rocket. And I don't know how much they actually bolt together, but most of the rocket pieces, including the engine and the rocket body, they're going to launch from Cape Canaveral or Kennedy Space Center. Um, and we'll see whether they're successful. But they could be a whole new player in launch to low Earth orbit. So that's happening. SpaceX is about to test this giant rocket, and I can't remember what the name they call it right now. But the really large one that's much larger than anything that's ever flown before, and that is critical both to getting to the moon because it's part of the NASA program for the moon missions that are upcoming, but also, of course, to extending our presence to another planet, namely Mars. Um, and that is supposed to launch here in March. So we'll see some news, and then Blue Origin uh, is going to start launching its first commercial rockets this spring, and so a whole lot of activity. It's literally almost a launch of something into space every day, and particularly it probably is every day if you look at what's happening in China. And India and other countries that are in the launch business. So we're at this very early stage now of sort of breaking out of the confines of planet Earth, um, and I think that it changes things in a couple of really fundamental ways. Number one, we think of Earth as a very finite physical system. And those in the environmental community will often say, well, we live on this finite planet and we're using up the resources too fast, or we're just spoiling the earth too quickly, both of which are true. Um, but in my opinion, they kind of overlook the fact that we live in a rather infinite universe and a pretty infinite solar system, as a matter of fact. And while it's expensive and not easy, or has been traditionally expensive and not easy to get to resources in space, space is full of resources, from water to minerals of all kinds, to hydrogen, to just everything that makes up material life on planet Earth exists elsewhere in the solar system. We just haven't ever thought of ourselves as we haven't ever thought of that as being accessible to us. So imagine a future 50 years from now in which that is pretty easily accessible. Maybe we've developed some kind of nuclear pulse rocket technology, which is under development, and other forms of enhanced propulsion systems. We might still use chemical rockets to get into low Earth orbit because it's still a very efficient way to get out of the gravity well of Earth. But once you're in low Earth orbit, then you could assemble spacecraft or put together craft that are already there that have, say, a nuclear pulse engine, and you can get to Mars in a matter of a few weeks. And from there, you can go other places, and the distances are vast, and the space is a hostile environment, and there's all kinds of challenges of overcoming it. But it is quite feasible now to think of a world in which tens of thousands of, or a future in which tens of thousands, and perhaps even by probably tens of thousands of people by 2073, eventually hundreds of thousands and maybe even millions of people living and working in low Earth orbit between here and the moon, on Mars, on certain moons of other planets, and so on. It's very science fictiony, and one can come with all kinds of um, apparently legitimate arguments for why would we want to do that? The planet is beautiful. Why would you want to go live in a place that doesn't have waterfalls and so on? All of that is true, but I think that the enhancement of the human experiment, um, and by human experiment I mean kind of a self-aware, intelligent species living in this solar system, expanding into the solar system is part of the potential destiny of being our species on this planet. So, and I, my take has always been, why wouldn't you want to do that if you're capable of doing it? It's obviously the next 50 years are perhaps the critical 50 years in answering the question: can we establish a robust enough economy with a preserved enough environment on planet Earth that these things are feasible? Because planet Earth, for a very long period of time, maybe forever, but certainly for a very long period of time, will be the base from which everything must come, or the where everything starts at least. And so you have to, the test is, can we begin to mitigate for climate change and actually reverse what's going on in terms of global warming, so that by 50 years from now we can say the trend now is away from global warming. We may not be actually cooling the planet, but at least we won't be warming it any further. And um, and have we established a robust enough economy that's sustainable enough that we can support all of these space adventures or ventures? And then can you build a self-sustaining economy in space, which I think there are lots of reasons to think that you can. There's actually a lot of theoretical work going on in universities and so on around doing that. Uh, and it won't be for everybody. Assume that 5% or 10% of people on Earth say, I think I'd like to be part of a space economy. Well, that's many millions of people who would say, yeah, I'd like to do that. Even if it's only 2 or 3% of the world's population say, yeah, I think I'd like to go off world for a while or for the rest of my life. It's a very large number of people if only a small percentage of the planet want to do that. So you have to develop the technological capability. You have to preserve the environment in such a way that the Earth environment in such a way that it's feasible, and you have to have a robust enough economy that it's feasible. If you do those three things, why wouldn't we do that?